Confirma's CADSTREAM system offers tremendous flexibility in designing hanging protocols to fit your individual needs. What is difficult for Confirma or its application specialists to do is to tell you, the physician, what hanging protocols you should use. This is really your individual decision. What's difficult as a physician, though, particularly if you're early on into breast imaging and unfamiliar with a Confirma CADSTREAM product, is knowing what protocols you want or even what protocols are available from your CADSTREAM product. In this section, we'll show some examples of hanging protocols that we use. You can use these as a guideline. You can use them just to give you ideas to develop your own hanging protocols, however it works best for you. These will be designed to follow the method or the imaging approach that we delineated in a prior section of our training video. Throughout this training program, we've tried to offer a wide range of imaging protocols, beginning with very basic protocols that are applicable to older MRI platforms, ranging up to more advanced imaging protocols for some of the newer platforms. In this hanging protocol section, we'll first start with some of our basic earlier protocols. You'll see that the image quality is not quite what you see with modern techniques, but I hope you'll also see the value still diagnostically with this imaging. This is an example of our standard or very basic imaging protocol that we began when we first started breast MRI. Again, following our approach to each case, we first start by evaluating the 1-minute subtraction Mipp images. You can see this image is not particularly beautiful aesthetically, but this is older techniques. But nonetheless, there is still a tremendous amount of information here. You can see the asymmetric enhancement within the right breast in this patient who had undergone a recent lumpectomy. This is clearly abnormal and asymmetric. Although not aesthetically pleasing, this has tremendous value diagnostically. You're able to toggle off and on color parametric mapping, which shows that very little of this enhancement actually reaches threshold degrees of enhancement, but it does demonstrate some degree of washout kinetics. The second pull-down menu that we have with this very basic protocol is really pretty simple. Designing imaging protocols or hanging protocols for this type of a basic technique is really not too tough. Once again, we show the 1-minute subtraction Mipp just to maintain as a reference as we're reading the rest of the case. In the bottom left-hand corner, we put our pre-contrast exam. We can put color mapping on or off depending on whatever your preference is. And then next to that, we put the 1-minute post-contrast image so we can compare raw data of pre and post contrast side by side. These will automatically be synced, so you just touch on either one and you can scroll through the images. Then in the top corner, we put the 1-minute subtraction image. This is a good way to, particularly in these early techniques when we didn't have fat saturation, we relied obviously on the subtraction to determine the enhancement. Here you can see the biopsy cavity in this patient with some thin enhancement around it, but there's some fairly significant asymmetric enhancement extending beyond the biopsy cavity, and there's also more focal enhancement as well. You can apply color parametric mapping to any one of these images as you feel necessary. With this same pull-down menu or hanging protocol, in addition to our pre and post as well as 1-minute subtraction imaging, we can show any other sequence that we have, and it automatically cross-references each image. Now in the right-hand screen you see from our early imaging technique the Fastman Echo T2 acquisition, where now you can see the biopsy cavity. Inferior to that is a STIR acquisition, very sensitive to edema. You can see the edema around the cavity and also see from the signal characteristics that this is a complex cavity, likely with hemorrhage within it. We then have a high-resolution coronal acquisition. Again, you can see the biopsy cavity in this region. And then once again, you have many options as to what you want to put here. We chose to do a thin Mipp image of the 1-minute subtraction acquisition. Again, any one of these that are involved with a dynamic run, you can apply the color parametric map to. The other advantage that CADSTREAM offers is being able to evaluate enhancement or signal characteristics on a single image by pointing to it, and then bringing up a cross-reference so you can evaluate what is the signal character on multiple pulse sequences. In this case, you can find it in the orthogonal coronal view, see what it looks like on T2 imaging, and additionally see what it looks like on stir imaging, which can be very important in many instances of pathology. Additionally, at any time, you can enlarge the images, migrate them to the region of interest. Again, if you're trying to evaluate this point of maximal enhancement and evaluate its stir signal, you can see that it's actually somewhat hypointense to the adjacent edema and parenchyma. With parallel imaging, you have options of axial or sagittal acquisitions. This is a hanging protocol we use for our axial parallel imaging pulse sequences. Again, following our approach to each case, the first thing we evaluate is a 1-minute subtraction Mipp image. In this case, you can see there's significant asymmetry in size of the breast, and there's obvious abnormal enhancement within the right breast. This patient has known right breast cancer, had a very large tumor volume by a remote exam, and is now partway into her chemotherapy, and they're evaluating for response. Again, you can just freely rotate the Mipp, evaluating both the right breast as well as the left breast, where you see lymph nodes in the axilla. Additionally, you can lay color parametric mapping over this. You can see there's some degree of background noise here at the low threshold level of mapping. Going to a higher level threshold, you can see there is still some background enhancement, but some of these areas of nodular enhancement do meet threshold with some degree of washout kinetics. The next pull-down option that we've designed is to apply cardiac suppression to the 1-minute subtraction Mipp image. You can see with the cardiac suppression applied, it eliminates all the signal from the heart and chest, accentuating the signal within the breast alone. Our next pull-down option is to evaluate the breast with thin Mipp imaging. We've set ours at 15 millimeters. There's nothing magical about that number. It merely provides a very nice overview image of the breast tissue. This is particularly helpful for our surgeons, and in all cases we will film this in an ordered way so our surgeons know exactly what to look for with each case. But you can see it gives a nice overview with more detailed anatomy than the 1-minute subtraction Mipps do, but of similar information. Again, you can see the abnormal foci of enhancement within the right breast. Our final pull-down option opens both screens for viewing, and we've set up a 4-on-1 view with each screen. This allows us to evaluate the raw data with the 1-minute subtraction data, with our stir data, and our T2 fast-spin echo data. Additionally, we can look at the coronal fast-spin echo T2 acquisition and still add additional Mipps in the remaining view boxes. In this menu, you look at the individual raw data simultaneously cross-correlated with other pulse sequences. As you pan through, you can see the individual foci of enhancement. Again, you can apply color parametric mapping and cross-correlate with your additional pulse sequences. This allows you to survey slice by slice through your images, simultaneously looking at all pulse sequences. This is one of the tremendous values of a CAD system, in that it can correlate multiple pulse sequences simultaneously rather than trying to sort through them individually. This hanging protocol is designed for our sagittal parallel imaging sequences. This is probably the most challenging pulse sequence to design a hanging protocol for, as we always like to look simultaneously at what's going on in the breast. We designed this such that we could look at both the sagittal 1-minute Mipp for each breast side by side. This allows you, again, your very first pull down, you get an overview of what's going on in the breast. You can obviously see there are abnormalities bilaterally within this breast that are very concerning. Applying color parametric mapping demonstrates high threshold degrees of enhancement in both of these areas. You can see there is some noise occurring here, which when you rotate is from a little bit of motion artifact in the sternal region. Our next pull down allows us to view the craniocaudal projection of these acquisitions, again the 1-minute subtraction Mipp. And we generally film this as well for our referring physicians, but it gives you an orientation of the abnormalities you saw on the sagittal Mipps, as to where they lie within the breast. Again, color parametric mapping is an option that you can apply, altering the thresholds to account for some degree of background motion artifact. Our next pull down is to do the 1-minute fat saturated thin Mipps. These again have been arbitrarily designed at 1.5 centimeter slice thickness. The images are again correlated with one another, and we generally always start medially at the parasternal region, identifying the internal mammary arteries, and we'll image this for our referring physicians. This again provides a very nice overview of the breast with much greater anatomical detail than we get on the subtraction Mipps. This obviously is applicable only with a more advanced technique where you require your dynamic acquisition with fat saturated pulse sequences. As on all other sequences, color parametric mapping can be applied to these as well. Our next pull down evaluates the raw data with multiple pulse sequences. It's at this point that we generally begin our dictation, looking at the right-handed screen where we're evaluating our stir pulse sequence and a T1 high-resolution pulse sequence. In this sequence, it allows us to start first looking at unenhanced imaging data, evaluating our stir sequence linked to our high-resolution T1 sequence. As you can see, scrolling through, evaluate lymph node morphology within the axillary lymph nodes, look for internal mammary lymph node involvement, and evaluating for unsuspected disease within the chest itself. Also allows us to evaluate the parenchyma in general, as well as cysts or asymmetric parenchyma or skin edema. On the left-hand screen, we have demonstrated our raw data with our 1-minute post-gadolinium fat-saturated pulse sequences imaged right and left superiorly, and linked with that are the 1-minute subtraction images. This is where you go through and do your detailed analysis, slice by slice, of the data, evaluating morphology of the enhancing lesions, again evaluating enhancement kinetics of the lesions. You can evaluate enhancement curves, or enlarge the images to evaluate more specific morphology. Again, you can cross-correlate with multiple pulse sequences, evaluating one of the enhancing nodules in the right breast, and cross-correlating its signal characteristics on the stir pulse sequence allows you to evaluate what it looks like on T1 as well as stir imaging, or if wanted, on a FASPIN Echo T2 non-fat saturated sagittal acquisition. Again, this greatly aids the speed and ease of evaluating multiple pulse sequences.